All right, hydrocephalus. This is abnormal accumulation of fluid in the cranial cavity. However, the mechanisms are very different between hydranencephaly and hydrocephalus. Okay, so hydranencephaly, full thickness necrosis of developing tissue. Got it. It's a brain tissue problem. This is a CSF production and flow and management problem. Does that make sense? Cool. Presentation is highly variable because there are many diverse causes. It's often subclinical. That is kind of species dependent. If you have a German Shepherd with hydrocephalus, more likely to be clinical than like hydrocephalus, right? Because they've kind of adapted to the amount of hydrocephalus we force them to live with. I love pugs. No hate. Another important part of this is that it's progressive or stable. This is not something that regresses. So once you have it, there it is. Quick review of normal CSF production and flow, because this is going to be important. It's produced in the ependyma by filtration and secretion of plasma. That's this guy up here. Then enters the lateral ventricle, goes through the intraventricular foramen. In the third ventricles comes out the mesencephalic aqueduct, which is the arrow right here. That's kind of above the brainstem, and then fourth ventricle, which is between the cerebellum and the brainstem, and then into the subarachnoid space. Here's that kind of dissected out here. The view you like. This can be congenital or acquired, but in animals, it's almost always obstructive. First is hydranencephaly, remember, which is necrosis of brain tissue. And then the CSF, it's not its fault, it's just there. It's just filling up the empty space. Congenital hydrocephalus, acquired hydrocephalus, these are obstructive. So the CSF is the problem. Congenital, these are malformations frequently of the mesencephalic aqueduct, which is that little narrow strip that goes above the brainstem. It's associated with other craniofacial abnormalities, this big domed heads. You can kind of look at these guys and be like, oh yeah, you got some hydrocephalus cooking in there. A lot of them have open fontanelles that may or may not close as they get older. And then this sunset strabismus, which is this bilateral ventrolateral strabismus. So we call them easty westies, or an achaphoia, because he's looking at you and he's looking for you at the same time. So this is very common in brachycephalic breeds. It can be an incidental finding on necropsy. We often get animals who the owners have no idea it's been a perfectly happy, Boston Terrier or pug or whatever for its whole life. And then, oh, it's a really bad hydrocephalus, like this much brain. So I guess it's fine. In other species and breeds, it can be sporadic, again, or congenital. Occasionally in cattle, you'll see like outbreaks with certain dietary deficiencies. All right, so congenital hydrocephalus. The key here that it's congenital is that there are other craniofacial abnormalities, and these are very young animals, right? So there's a bonus here. What's the bonus lesion? Something about the gyri, this right here?
The cerebellum.
So this is the lesion. There's hydrocephalus in here, and the ventricles have deflated. And so the brain's like, ooh. So that's the hydrocephalus. Where's the cerebellum? Is it gone? Or was it never? It was never. Right. So what would you call this?
How do you know it was never? How do you know something? Take it off.
How do you not know it was never?
Taking it off.
That's true. Someone could have taken it off, but they didn't. So my point is, these are congenital lesions because there are other congenital lesions in the picture, right? So this guy has cerebellar aplasia. Yeah, you're like no, right? Aplasia is failure to form. This guy. So this is the normal brain. What do you call this? Smooth brain. Yep. Lissencephaly. Good. So normal in a mouse. This guy, see, he's kind of deflated because of his massive hydrocephalus. Look how big his skull cavity is compared to this guy, and his eyes are getting kind of like pushed out of the way. Another view of a mouse. I'm a lab animal person, so you're gonna get extra mouse stuff from me. Sorry, not sorry. Just pretend they're like tiny dogs. So see the big dome head here. This is not a spina bifida atrophy. This is just a sick mouse. They get punched when they don't feel good, and they kind of. Here's another. This guy probably has congenital hydrocephalus. He looks a lot like this guy. Self-explanatory. Massive dilation of ventricles, and this is compression atrophy of the remaining brain tissue, right? All right, acquired hydrocephalus, also very common, not usually associated with other craniofacial defects. And this is the result of obstruction, but instead of stenosis, it's by either an exudate or a mass effect most commonly. So any kind of meningitis where you've got exudate kind of driven into your ventricles. FIP is a big one. FIP often affects the brain and can frequently result in obstruction. That very thick exudate, you could actually, I think I have an image later, but when you cut into the ventricles, they're full of this really, really high protein exudate. So it looks kind of like somebody put Jello shots in the ventricles. It's really cool. Neoplasia, parasitic cyst, and then this is a horse with a cholesteatoma. I was going to ask you to figure out what that meant, but I guess I already gave it to you. So this is a cholesterol granuloma that forms, we're not really sure, maybe because of chronic hemorrhage in the choroid plexus. It's a horse thing, but these can get very large and frequently result in obstruction. Yeah, there's the Jello shot brain. Look at that. Isn't that beautiful? So what's the protein in there? Fibrin. There's lots of fibrin in there. So here's an example of meningitis, and you can see this is the mesencephalic aqueduct, and it's loaded with crap. Another cholesteatoma. Mass effect, important identification of mass effect is this midline shift right here. So you can see if you try to cut line, can't do it. So mass. And then this is a primary brain tumor, oligodendroglioma, form in the ventricles. So anything that causes compression of any of these structures. All right, so pop quiz. Is this Hydranencephaly or Hydrocephalus, and why? And is it congenital or acquired? Hydranencephaly. Hydrocephalus. No clue. Okay, let's do the other one first because it's easier. Is it congenital or acquired? Definitely congenital. Why? Two problems. What are they? The cerebellum. What is this? What is this? Name it. Aplasia is no cerebellum. It's not too small. It is too small.
Like that.
I'm asking you guys to think out of the box. There's no way you would know this. We're just having fun. This is segmental aplasia. It's missing a segment of the cerebellum. But look, the segment that's there is normal looking, right? It's not too small. So it's not hypoplasia. It's segmental aplasia. Okay. And then what's the CNS defect? You guys thought hydranencephaly. Why do you think hydranencephaly? Because there's no brain tissue. You can get no brain tissue with severe hydrocephalus too, right? Your pub. There's one more congenital lesion in the picture you guys have. This is a calf. What are calves' heads shaped like? Like this? No. So he's got a domed forehead. This is hydrocephalus. All right. Oh, we're almost there. Any questions? There's so many. All right, cerebellar defects. The cerebellum is uniquely susceptible to these developmental defects. because there's a lot of late gestation and even postnatal cell migration. It occurs in 3 different waves. So cerebellar defects are extremely common in animals. This is kind of the frequency. Cats are kind of the one we always think of and see in all the YouTube videos. Clinical signs are related to abnormal cerebellar function. So these are kind of the 3 breakdowns of cerebellar function. You can have vestibular balance problems. You can have issues with coordination of your limb and body movements, so all over the place. And then composition of complex movements, which is why they have intention tremors. So as soon as they try to focus and do something complex, they're like, I can't do it. Comes in several flavors. Cerebellar hypoplasia is the most common. You can also have dysplasia, agenesis, aplasia, partial or segmental aplasia. Cerebellar hypoplasia, I'm sure you guys know what this is, right? Everybody knows cerebellar hypoplasia. The one of the most common congenital CNS defects in animals. Kittens are kind of the famous poster child. This is another one of my favorite YouTube videos. Have you guys seen this guy? It's a cerebellar hypoplasia dog dancing in the mud, and he's so happy, but he just can't. That's great. So most of these cases are associated with an in utero viral infection. Feline Pan-Luke is the one we think, but you can always see it with these other guys. It's just less common. The extent is variable, so they can be grossly normal with just some dysplasia that's seen microscopically, or you can have just like nothing there but tissue nubbins. And it's often what is there is combined with some degree of dysplasia. So
I don't know if you answered it, but my question was going to be, what would be like, how would you tell it's dysplasia from hypoplasia?
Microscopic. If there's hypoplasia, there is probably also dysplasia under the microscope. Yeah, dysplasia here is a microscopic term. Other questions? Right, here it is. So this would be aplasia or agenesis. There's no cerebellum there. This one's almost normal, right? If you didn't have this other brain here to look at, you might be like, oh yeah, that's a normal size cerebellum, right? If you didn't have the comparison, that'd be hard. It'd be hard for me. Here is what we have. So you can see that this is cerebellum, right? You can see the white matter and the gray matter, but there's not enough of it, and it's not big enough. So this is hypoplasia. I know, right? And then look at this. What are you trying to do here with this little cerebellum babies?
So
Yes.
you go back to the one with the 2 brains. Is the cerebrum on that other one also a little bit affected?
I
Just
think so. It looks okay. Fresh brains are kind of hard. We don't usually look at a lot of fresh brains because they're so soft and so fragile. What we literally do is we take them out of the skull, we look at them on the top, and we flip it over and we look at them in the bottom, and they're like, that looks good, put it in formalin. And then we don't really examine it until we take it out of formalin and it's firm enough that we can actually slice through it and look at the slices. So this brain's just probably kind of floppy. It's probably just like, ooh. Yes.
In the time that you're taking the brain out and putting it in formalin, do you lose any lesions or do you lose any potential?
I mean, it depends who's doing this. If it's one of you guys, sometimes, yeah. We're like, touch it. All right, storage diseases. So we talked about these in GenPath. They come in a lot of flavors. Most of them affect neurons and macrophages, and sometimes the liver or kidney. Basic concept here is you have either a deficient or a defective lysosomal enzyme that leads to accumulation of whatever that enzyme substrate is in the cell. That's then an undigestible thing for the cell, and it accumulates over the lifetime of the cell. So can you guys think why neurons would be extra susceptible to this? Good, you can. Is anybody going to tell me? Neurotransmitters. So they're filling up with stuff, right? They don't have room for neurotransmitters. But why would a neuron be more susceptible to that than like a skin cell?
they don't regenerate.
They don't regenerate. Yeah. So these are terminally differentiated cells. Your neurons are there for life, and they just start slowly dying. I'm evidence of that. You guys have more brain cells alive than I do. So yeah, these are terminally differentiated, very long-lived cells. So over the lifetime of the cell, as these accumulate, it has no way to deal with them. So neurons are very susceptible. So this eventually will result in death of those neurons. Most of these are inherited, it's autosomal recessive. So these present typically at a young age. It depends on the flavor of disease, what the substrate is. Some of them go more rapidly than others. There are also some toxic forms that we see occasionally in grazing animals. They eat this and they can toxically inhibit the lysozymes. The morphologic hallmark is these big swollen neurons containing large vacuoles that crowds out everything else in the cell. The cell will eventually become non-functional and then eventually die. These are some classic human storage diseases. If you guys have heard of any of these, there are animal equivalents of these as well. Here they are. Please don't memorize this. So there's a lot of them. Basically, the point. Yeah.
Do you have that slide memorized?
I did at one point. Actually, these are humans, so I didn't memorize all of these, but I had to know a lot of these for boards. Crab disease. That's when your neurons fill up with crabs. Okay, so storage diseases, not often grossly visible, but sometimes you get lucky, as in this case, which I found from 1978. So this is spinal cord, and these are peripheral nerves. And once you have disrupted the meninges here, these peripheral nerves are like bulging everywhere. So this is due to the microscopic appearance, which is these large, swollen neuronal cell bodies. So this purple stuff, this is Nissl substance. So this is the endoplasmic reticulum of the cell. Usually fills the cell body, but all this pale, white, vast nothingness is all storage product. And these guys, you can see it here. It's this fluffy looking vacuolated cytoplasm. This guy's good because you can actually see his nucleus. This guy's dying. His nucleus is like. And then on EM, these look really cool. So often EM is needed to actually definitively diagnose which storage disease it is because you need to look at the product. And these are, this is electron microscopy of the actual lysosomes, filled with undigested substrate. These are called zebra bodies or something. Okay, so questions on congenital defects? Sweet. What?
I just thought the TLDR was funny.
Okay, so lab today is going to be right here because we're going to do some cases. So 10-minute break.